Good day. Today's topic will be about the electron and with the vector or the site of the chemical vectors like orbitals and the Paris exclusion method or principle and something else like. And for second video will be continued to the within the wave vector in the chemical vectors and how they will be connected to the probability of the wave function and why it will be linked to the semiconductor productions. So let's see. With the chemical vector, the orbitals, we know that if there is a material like silicon, oxide, or hydrogen, carbon, anything else. So see, if there is a carbon, maybe carbon was the 14, right? Then 2, 8, and 4. For the last exterior orbit have 4 electrons. So it can be mean as for the first s orbital we have 2 electrons. For the first orbital 2 electrons, and for second same 2 orbitals, 2 electrons, sorry. And for p orbitals with the magnetic quantum numbers, we will divide 3 vectors, so they will be each by 2 and 2 and 2. Then, totally 8. The rest of 4 can be connected as for the third s orbital with 2, and binary. For the second p orbital with magnetic number, there will be 3, but 4 only first room if it is very stable. Look at the -1 of the magnetic quantum number. There will be 2 samely. So totally 14 electrons in a carbon atom. So why I'm speaking about the chemical vectors of electrons stating in the carbon atom? So see, we know that orbital will be connected as although we have learned in the high school strategy or some middle school strategy in chemical class, for the S class. So for the S orbitals, they will have 2 electrons that have been up-spin and down-spin electrons by the principle of the Pauli exclusion of electrons, which means electron will have spin. Something will have the positive or up spin, and another will have the opposite of this one. So we call this as the down spin or opposite spin. So by the up and the down spin of electrons with 1 each pair, they will have 1 pair of electron pair by 2 in each orbital. So for the S, they will have only 1 room, which can be said as 1 vacant room for the electrons for a pair to stay. So anyway, for the S orbital, since it is N1, for the S orbital, they have only 1 room, so they will have some spherical, so they will have only 2 electrons for vacant. And so for p orbital, by the magnetic quantum numbers, they will have about 3 rooms, 2 by 2 by 2, and for D, maybe there was 6 and F, 18. But for today's lecture, we don't consider about the D or F orbitals, so by the energy quantization of the level, when more and more electrons get gathered in an atom, or by the bonding or anyway, such as covalent or chemical or metal bonding anyway, or first 2 and capping. But we should know that by the difference of energy state or level or height, after 3p there will be considered as the 4s if this is a stable state for electrons or atoms. So, but if after making the 3p orbital full of the electrons, next really was 4s, but the next electrons that entered in a vacant room had enough energy or so make some assumptions. There is a hotel that only ensure 2 people or 1 couple that have 2 persons in a team. So the hotel manager said, "Greetings, but we only have vacant room for 2 people in 1 pair or couple. So, first couple will enter as 1S and continuing and 3P and 4S and 3D. So, but after the people or the couples join the 3P rooms, the last couple must join the 4S, but they have somewhat enough money or they have paid higher money to enter the 3D orbitals. So it can be stated as I have higher energy for the couple can be meant as the electron pair. So they have higher energy. They jump to the breath and get into the 3D state room. So we can know that, oh, there is a vacant between the 3P and 3D. That is, the vacant room is 4S. So using these factors, we can draw some graph like this. The vacant vectors or the vacant gap can be continued as the gap or the empty side of the energy state. So we call these factors as energy gap. So getting to the point, we know that wave vector's absolute square value is the probability of the electron stating in atom or orbitals. So for first is C. So we speed in main direction of S or Y or Z. So anyway, if you have some spherical wave that electron can state, and for p orbitals, maybe some polarity. So when spinning, for the first minus magnetic quantum number of second p orbital will be some will have some heliquantal waveform that can be stated as a butterfly's wings. So, getting more point, 3p, somewhat complicated, so we will skip these factors. So let's assume if the 3 atoms of helium get covalent bonding, so the potential energy state of the graph will be like this. Each helium's atom of positive 1, then the each electron's wave function's absolute value of the square can be stated like this, which means there can be the probability of the electron can state in 1s orbital. But we know, as before I said, there can be a jump case to not going to the another orbitals, or some sectors of orbitals that we must go, or the electron must go. So for this case, so guess if the 3 electrons were full of room, for first, one has a spin and down spin, 1 pair of 2 electrons. Okay, there is 1 remaining. So the last one have choice. If these last electron have higher energy or enough energy to jump up, it can skip the 2s and go to the 2p orbitals. So we see, oh, the internal orbital and the external orbital have some vacant room or vacant energy gap. So when taking in the graph, we see there is some gap between the energy levels by 1s and 2p. So we call this gap as energy gap. And we know the energy gap is some region that electrons can't state. So back to the point, we can draw this graph as with a vector of conduction band and valence band. So the valence band means electron is surely stating with some stable point or stable energy state. And for conduction band, here is no electrons for assuming, but if electrons get higher energy, something like getting hit or thermal activation or something strong like a laser or the sun. Anyway, so here then we call this factor as electron and Hall pairs generation. So Hall maybe can be the opposite vector of the electron, and electron something that have negative charge. They will apart. So plus charge of Hall and negative charge of electron. So if they, so electron will go up as the electron have get energy. So using the conduction band, and if the electron get more energy, then it will somewhat break the limit of the vacuum energy level state. And we call this as something like free electron. Here. So see, the height of R means some ionization energy. If the so getting to the point with hydrogen have only one electron. So to make the hydrogen ionization, electron must have high energy to excite from the effect of the Coulomb effect of the nuclear that have positive charge to pass the attraction force. So ionization energy level or quantity, right? And for chi here, from the conduction band to vacuum energy level state. So it means if there is some electrons like a metal or some excited material like silicon or carbon. So anyway, if there is electron and the electron got energy higher, then if they get energy, they will be freed, like free electrons. So we call this energy level state height difference as the electron permeability. How the material catch where or how, so simply saying, how the atom loves the electron. So electron permeability means if to make a one electron free electron, we will need about the chi factors height energy to make one electron free from one atom. So simply think, for the insulator, the gap between the conduction energy and balance energy band is quite heavy or quite strong. So it will require quite or very high energy, a high energy level. So electron is very hard to came up from the insulator, but with the semiconductors, somewhat decrease distance between the conduction band and valence band. So maybe some are more easier than the insulator one case, but with the metals, conduction band and valence band is quite closer. So just getting some electrical wave or field, the electron will be attracted by the force of electrical wave, or yes. So metal is some cold conductor since it can carry up electrons very high density. So with insulator we can call as the resistor or capacitor in DC. Of course, the resistor is not insulator, but just in case the electron is heavy to be came out. And for semiconductors like silicon, so using the semiconductor metal that have somewhat quite height difference between the conduction and valence band. So it means if we dope with many electrons to be created, it can similarly work as metal or something like or something closer to the insulator. So okay, this is why we talk about chemical factors and relate to the energy gap and the valence band or conduction band, and why we should talk. So getting to the next free and wave factor. Okay, so second picture on the topic with the frequency and the wave function, and that has something periodic and sinusoidal, and how can we relate it to with the electrons probability of stating and some energy or the potential graph. So before getting to the point, say about the Fourier transform. What is Fourier transform? Well, saying with what he said, Fourier said, if there is some periodic but some complicated wave function that have periodic pattern here, but if we make this as the equation, there can be large of a big wave or sinusoidal, and something that have small but have fast frequency sinusoidal over here, and so we can see there is some complicated function that have periodic, then we can make the disassembly of this wave function that have periodic into the simple wave functions that have periodic features. So maybe will the first one be the second that have offset and both best period, and one more best. So like this, somewhat simple but have many factors of the sinusoidal patterns will be stated in a complicated graph. So till now we talked about the time domain time domain wave vectors. So first, big one and short frequency and higher frequency more but have some lower amplitude, so like this. So arrange this in the frequency vectors, how fast frequency have, from starting from 0 to more higher frequency, then maybe converge to the diverge to the eternity. So 1 Hz, 2 Hz, continuing. So for the big one and smaller amplitude but faster, it will be continued. So when seeing this, we can see how many hertz that has been combined in a cone structure or some of this structure. Something like histograms. So for 1 Hz, 2 Hz, 4 Hz, 8 Hz, 32 Hz, continuous. So with K factors that have special frequency domain or some Hertz domain or frequency domain, by the frequency increase, the more and more graphs will appear that have sinusoidal and periodic patterns, from the complicated one to simpler but many vectors of sinusoidal patterns that have periodic features here. And with the Fourier transform and seeing by the vector of the frequency domain, we see at which frequency domain how the amplitude or how many graphs are stating in the complicated graph. So simply think, first, there is one wave vector, a factor or wave function that has periodic but somewhat complicated. We can't use in our hand to pencil. But disassembling the vectors of the sinusoidal patterns. So if we disassemble this complicated graph to the sinusoidal periodic graphs that have some easier we can see and draw, there will be lots of vectors that have contained in this graph. And arranging in a frequency domain, there will be lots of graphs that have each by each different frequencies. So this is how we transform from the time domain to frequency domain. So why I told this vector will come out later. So getting to the point, for the last week we told if photon that have energy and accelerated hit by metal surface, then there will be two vectors. For first, another photon will be scattered to another vector, and second, one electron will be came up from the surface and go to another direction. So like this, electron or photon here. So we say these electrons have both potential energies and kinetic energies. So the total energy state can be stated as combining the potential energy level and the kinetic energy level. Potential means this one, and kinetic means moving up from two directions. So the kinetic energy state equation will be like this. We talked a bit this about the last week's vectors class. So we did the wave vectors that related to the potential energies and the kinetic energies with the wave vectors. So we can set like this of how an electron have energy and how it move. So if the wave number or the k is in a positive state, then it means within the time domain with x, the electron is moving to the positive propagation or directions. If the k is in a negative position, it can be meant as the electron is propagating or moving to the negative pole. So total energy state is for the photon is h, the constant of Planck, and the frequency. So setting again h by multiplying the angular frequency with mean as w here. So angular frequency is stated as h bar h 2 pi r over h bar. So let's see if there is an electron move. So we told the current is dq over dt. What does this equation mean? Within the time domain vectors, how many charge passed in an area and how fast and how many electrons have passed in the curtain area and passed through this area in a time or some set time. So anyway, this is the relation and how we think about the current amount. So we can consider this. So if we want to get more power density or more power consumption, if there is more electron pass, so in simply, if more carriers pass or charges flow more fastly and more amount, we can make some stronger power in a device. That's right. So for first, velocity of carriers, and second, how many, and third, wave number k. So maybe the velocity and the first mass. And we know, let's take our assumption. I stand here and suddenly a baseball came flying to me. If a man throw the ball with lower power and lower speed, maybe I can feel the 200 gram of baseball as 1 kilogram soccer ball had hit me. But if the man was angry and throw the baseball with powerful amount, then maybe the baseball will came with faster and more higher energies. And if I've been hit with the same case of the ball that is the same baseball, I can feel this. Oh, it's quite painful, and I felt like this as a 1 ton truck is coming up to me. So we call this the feeling something the difference of mass as the effective mass or mass effect mass. So considering the wave velocity, the group velocity, here group velocity means if there is two waves that have another vectors. something is sinusoidal and something is of course sinusoidal but pattern but have different amplitude and frequency. So if they met, they will have some grouped page that is continuous and periodic. Just a moment. So my truth, if a wave means can be set like this. We can draw the constructor on this structure continued. So each norm of the wave vector will flow to the direction by the time path. So we call this how the best of the norm of the wave is moving best by the time is the group velocity. So group velocity can be said as ds over dt, baby, can be said as the time over that is settled under the distance. So we call this, this is the wave. We can set again like the 1 over h bar multiplying the d energy on over dk wave number. So I say total energy is sum of the potential energies and kinetic energies. So kinetic energy of an electron can be stated h and k square of over the 2m. M. So dividing one more time, the second derivation of this equation will be said as the h bar square over the mass of electron. So here we can guess, oh, then the mass of the particle stated as h bar square multiplying 1 over the second derivation of these equations. So we can say, if we know the second derivation of this energy over the wave number, we can know how the electron is moving faster and how we can say the energy it have. And finally, how can we feel this with mass when we get hit? Just describing not being really hit. So, using this graph, if the curvature of the stiffness is more higher, then it can be said as if the stiffness or the curvature is more higher. So in short, if the second derivation of the equation is more higher state, then there will be more electrons mass effect heavier. In opposite, electron will be quite heavy since there is lower energy state, right? And it can be said as, if assuming the electron have same mass each by each, then the mass difference, of course the original mass is same, then what will remain? First is multiply acceleration. So if the force is different, but we say mass is same with each by each electrons, then acceleration is faster or lower. So we can state, so we can consider that electron have more energy since it have more accelerated, or in other side, the electron have lower energy since the acceleration is quite lower or the velocity is lower. Okay. Okay, so finally we talk for the first factor of this class with the second videos. We talked about free transform. Change the complicated graph or the pattern of that have the graph from complicated but have the periodic function can be disassembled by the large of some of the sinusoidal patterns that have periodic features. So if the propagation graph of electron is periodic, then by the periodic factors, we can select it by the periodic term by term for the periodic condition. Then the equation of energy can be stated like this. So If periodic wave is apparent, like this, we can state that have some amplitude and multiplied by the exponential. We know the exponential by the Euler's law. Exponential j omega is cosine omega plus j sine omega. So using this the Euler's equation, maybe we can state the wave vector or the wave vector of the electrons propagation or moving as the sinusoidal patterns, and maybe we can use it as the Fourier transform, and finally we can show it out as the k vector or the wave number or the spatial frequency domain vectors. So here's the condition. If there is some periodic graph, if we know about just one periodic term, pi a or 2 pi a plus minus, then the length will be about a over pi. So if we know about the periodic, if we want to know about the periodic vector of this completed graph, just cut the length by a over pi. Then we can have one periodic term of the periodic graph. And if we disassemble this by from the time domain to spatial frequency domain again by the Fourier transform, or some like with the free or frequency domain, we can know how the electron is moving best, or how the effective mass the electron have, and finally how many energy will have. And conclusion is by the three factors, the mass, the velocity, and the wave number or the energy that have will determine the probability of the electron is stating. And by this, for the first class of the video I said, we can assume how the probability of the electron is stating will be stated, and finally the energy gap between the conduction and valence band will be stated. Okay, thank you for listening.